Hi, everyone. Welcome to today's event, Generative AI Fundamentals, an insightful journey into the world of artificial intelligence. My name is Jenna Jordan, and I am the event marketing and alumni specialist here at Hack Reactor. So I have the chance to put on some of these events for you all to learn a little bit about some hot topics and a little bit more about our programs. I also, in my role, have the chance to work with our amazing over 14,000 alumni. So very excited to be with you all here today. In the event today, we will start with the basics of AI. We'll then delve into machine learning and deep learning, exploring how these technologies learn from data and improve over time. We'll also get an in-depth look at generative AI, including latest advancements like ChatGPT, which has seen a remarkable adoption and impact. We'll also have a hands-on session with ChatGPT later on in the event. If this is your first time joining us for an event, welcome. Here at Hack Reactor, we have a portfolio of transformational coding bootcamps that will prepare you to become a full-stack software engineer. And I'm really just here to give you all a few housekeeping announcements before we jump into the event. So we would love to answer all of your questions, and we'll encourage questions throughout the event. So please go ahead and use that Q&A feature that you'll see at the bottom of your Zoom screen to go ahead and submit all your questions. Daniel will pause for questions throughout the event, and I'll be able to have him get all your questions answered. In these events, sometimes we can have an inflow of questions that we may not be able to get to during the event, or if they are on a topic other than what we're covering on the event, we will try to answer them in that Q&A chat. We'll also present our contact information at the end of the event so we can make sure to get you all our info so we can get all your questions answered. That is all the housekeeping. So I'm very excited to go ahead and pass the mic over to Daniel to go ahead and introduce himself and kick off the event.
All right. Thank you very much, Jenna. All right. Thank you, everybody, for joining today. My name is Daniel Billett. I am the Director of Curriculum for the Hack Reactor team, and I've been working with boot camps for about 10 years-ish. Have helped to start a couple of them. I've spent a decent amount of time in the classroom, and then at this point, I most of my work is writing curriculum for the classroom. Before that, and actually throughout that, I am a software engineer at heart, and I've been doing software engineering since, I guess Web 1.0 in the 90s. So it's been a bit, and it's a career that I very much enjoy, and I'm very excited to share with y'all. So to begin with, let me share my screen here. I love Zoom. It seems like they like to change stuff around on us as often as possible. There we go. Can you all see the presentation there? All right. Okay, so before we get into the meat of things here, I want to start with just some myths about AI. Does anybody have, I'd like to see, go ahead in the Q&A box there, if anybody has any myths about AI that they're aware of, or anything that kind of maybe scares you away from AI or programming as a career. I'll wait a couple seconds for, 15, 20 seconds for any questions. Yeah, I see one question here. How can a full stack engineering bootcamp help get a job in generative AI? Some of that will be answered throughout the presentation here. But I would say that becoming a software engineer is your first step to having a job in generative AI. So learning how to program would be the fundamental first step of that. However, as you are learning how to do it, you can use AI, generative AI, both as through your learning journey, to help you learn more effectively and more quickly, as well as use it as you learn how to program to make you a more efficient software engineer. How do we keep AI from taking over? You know what? That's a good segue into the first myth that I have here. So let's jump forward into that. So common myth number one, AI is going to replace the need for software developers. This is not going to happen anytime soon. With the current generation of AI, now let's be real. AI has grown in explosive ways over the last couple of years, and it's truly amazing in different ways. And I'm amazed by it on a day-to-day basis. But I have yet to see anything that is even close to having me scared about my own profession as a software engineer. Most of the things I see just make me more happy to be in this profession as a software engineer and able to take advantage of these to just write better code faster. There was a study published by the RAND organization, I think last month sometime, basically saying that a lot of companies had spent billions of dollars, really wasted, I believe is the term that they used, billions of dollars, and at this point seeing not the returns that they expected. There's companies who've really put all their eggs in the basket of thinking that AI was going to replace software engineers, and those companies are going out of business in droves at the moment. I think the people that have been software engineers for quite a while have been confident in this for a bit, ever since the beginning of this wave of AI. And so, look, is this going to happen at some point? Maybe, but the current wave of AI is nowhere close to that. There's a benchmark that studies that looks at how effective AI is at different tasks. There's specifically a benchmark about software engineering and coding tasks, and AI can effectively do about 5% of the tasks in there. So that leaves about 95% of common software engineering tasks still need to be done by humans. And that 5% of stuff that AI can do tends to be the mundane parts of software engineering that you don't really want to do. And so thankfully, AI is there to take those parts for us. Let's jump into common myth number 2. I don't need to learn how to program because AI can do it for me. Well, this is really kind of the other side of the coin from what we were talking about before. If AI is not replacing software engineers, then that means software engineers have some kind of mojo, call it what you like, that AI can't do. And what that is it's human knowledge and the ability to problem solve. Pardon me one second. Yeah, so as I said, in the AI benchmark, 95% of the tasks in there AI cannot perform. So if you want to be a software engineer, just like I would say go back to 50 years ago, you need to learn how to program. It's fundamental. There's no way that AI can replace the core understanding of how to program. And one of the things that we'll see later is that AI is not perfect. AI can do things that are wrong and it doesn't know. And so to effectively use AI, you have to understand programming well enough that when you're using AI, you can identify and spot the places where AI has done it wrong. And human is just absolutely necessary at this point for that. So those are the two main myths at this point that I think I've heard some students concerned about as they're looking at following a job as a software engineer or joining a boot camp. So let's move forward. So with that stuff out of the way, what we're going to cover in this talk is I want to give you an introduction to the vocabulary of AI, basically from the word artificial intelligence itself all the way down to the tools that we're using like ChatGPT. We're not going to go into a whole lot of depth because you could do an entire PhD on probably any of these slides. But what I'd like to get y'all is basically the vocabulary to have a conversation about this. And pardon me. And so that we can do the second half of the presentation where we'll learn more in depth about large language models and how to use ChatGPT itself specifically. All right, so let's dig into it. All right, AI, machine learning, LLMs, what's the difference? If anybody wants to throw any stabs at that into Q&A going ahead, if not, that's all right too. All right, let us move forward. First off, artificial intelligence. What is artificial intelligence? This is the broadest term of all, and it really refers to any system that has the capability to perform tasks that typically require a human or human intelligence. This includes learning, reasoning, problem solving, and understanding natural language. AI can be seen in pretty much all different sectors, from healthcare, e-commerce, autonomous driving. I don't know if where you live you have autonomous cars. Where I have, they're all over the place. It's been pretty incredible. and of course, generative AI itself as a field. So artificial intelligence covers all things in this field. And as a trivia point, artificial intelligence is actually one of the oldest parts of computer science. It actually got its start in like basically the 1940s and 50s. And believe it or not, as soon as there was computers, human beings started wondering, hey, are these going to replace me? So let's jump. Basically, we're going down a rabbit hole here, and you'll see that as we jump down it. So let's go to the next layer of it. So within the realm of artificial intelligence, we have what's called machine learning. And the machine learning is a subset of AI where the program can learn about the task that it's supposed to do. Now, this is opposed to actually having to manually code out rules. So artificial intelligence that's not machine learning requires a lot of coding that says, if this, do this, if this, do this. The thing about these types of artificial intelligence systems is if you want to change them or add to them, you actually have to go into the code and change the stuff. The really cool thing about machine learning is it can learn based on data you give it without changing the code that it's based on. All right, let's jump down the next layer of this rabbit hole. Within machine learning, there's a specific technology called neural networks. And this is a class of machine learning models that are inspired by the structure of the brain. In this structure, artificial neurons, just like the neurons in our head, are trained by positive and negative feedback system as training data is fed through the neural network. Now, when I said it's just like the stuff up here, it's not exactly like it, but it's a very, very close analog and does work in a similar way to your brain of neuronal connections getting stronger or weaker based on the experiences that you have as a human. A machine learning system, as you give it data, that's basically its equivalent of experiencing stuff like a human does. One thing I'd like to point out is there's a number of different, we'll call it technologies within machine learning, and they all are interesting, and some of them are applicable to different areas. But over the last decade, neural networks is where we've really seen the biggest advances in AI. All right, let's jump to the next layer here. So what we're going to do from here is we're going to jump into neural networks specifically and see that this is going to blow up again further and further down the rabbit hole. Okay, so here within neural networks, we have a situation kind of like this. The language models that I have here, this represents an application of neural networks. This isn't a specific type of neural network, but it's the problems that the neural networks are applied to. Other problems that you can apply neural networks to are like image categorization. So you could have a neural network system that once you train it, you can give it an image and it can say, hey, that's a cat, that's a dog, that's a bird. This is called a categorization task. But here specifically, we're looking at language models. Language models are any models that deal with human language. And that can be generating language, summarizing language, translating from one language to another, but pretty much anything having to do with human language. Now, in this way, darker blue circle, we have what are called transformers. Transformers are a specific type of neural network or a technology that was really introduced to the public at large in 2017 and is part of the reason why AI has really taken off in the last handful of years. Transformers basically allow your machine language model, machine learning model to be trained on truly massive sets of data in an effective and efficient way. And effective because at some point with previous technologies, once too much data is fed into it, the model loses the capability to draw connections, I'd say, that are further and further apart. When things are really close together, it can draw connections, but it starts to lose that ability as stuff gets further away. Transformers allow it to draw connections across very broad pieces of data. And it also allows neural networks to be able to process, like I said, truly massive amounts of data. And by massive, I mean like the entire internet as we know it. The LLMs that we work with, ChatGPT, Bard, and et cetera, they're basically trained on the entire internet. And that's truly massive. So where we have the intersection here of language models and transformers is where we get this term large language model, or LLM. And you will see that if you dig into any AI stuff today, you probably won't be able to read more than a sentence or two before you run into the term LLM. And again, that stands for large language model. So again, these are models that work with human language, but they are large because they use transformers and can be trained on, again, massive, massive sets of data. So within this realm of large language models here, we have what are called GPTs. In the next slide, we'll dig into that a little bit more. Okay, so this is GPTs. And first off, what does GPT stand for? GPT stands for Generative Pre-trained Transformer. So let's look at the word generative to begin with. Generative AI is actually part of the title of our talk here today. Generative means any AI model whose purpose is to create new content. And some of you might have played with some of the image generators out there like DALL-E, which can be very interesting, fun, possibly disturbing, depending on what you ask it to do. But generative, these types of models can generate images, they can generate music, they can generate all sorts of things. As programmers, the medium we work in is text. So the type of models that we are most interested in are models that generate text. So that's the generative part of it. Pre-trained means that because the transformers can handle truly massive amounts of data, the models are pre-trained on basically the corpus of data, which is the entire internet as we know it. But then they can be trained for different purposes. And we can see two of those core purposes down here in the smaller, darker circles here. One of those purposes is chatbots. And so that's where tools like ChatGPT, Google Gemini, or Anthropic Claude, these tools all work very similarly. And again, the chatbot part of training is a training that is put on top of the pre-training of basically the entire internet of information. The second way that you can train a GPT is as a code assistant. We won't be talking about those today, but that is a topic that we cover in our boot camps. But just to name those, some of the code assistants are like GitHub Copilot, Amazon Code Whisperer, Tab9, and Codium. And these coding assistants are basically tools that work within your development environment to help you write code quicker, more effectively, and to do some of the mundane type of code that we have to write from time to time. All right, that is a lot of vocabulary, and I think I went through it pretty quickly. So I'd like to take a minute for questions about that, if anybody would like to ask any questions or get any clarification on how those things fit together. Don't be shy if you have any questions. There we go. There's one. Is a transformer a type of hardware? No, it's a very good question. It does sound kind of like an electrical transformer, but it is a specific configuration of a neural network. And so a neural network, just like the neurons in your brain, and we all know that all humans are different, and ultimately that's because our brains are all wired a little bit differently. And so neural network in a computer can also be wired in all kinds of different configurations. And so a transformer is a specific configuration of a neural network. I think if you want to look into that further, there's an article, the article that introduced transformers to the world as we know it. The article is called, I believe it's called All You Need Is Attention. Attention is all we need. Attention is all you need. Sorry, I don't have that right in front of me. But that paper was published in 2017, and like I said, has really been transformational in AI kind of taking off the way we've seen it over the last 5 years. Yeah, 5-ish years. Any other questions? That was a good one. Thank you. And please don't be shy. This is a great time to get these questions out of the way. And I want you all to be able to go away from here and talk about AI to your friends and family and loved ones, et cetera, and feel like you know what you're talking about, or be able to do further research. All right. Well, there'll be time for more questions as we get towards the end, and even before we get there. So let us move on now that we have vocabulary out of the way. Pardon me 1 second. There we go. I got just too many windows going on here. All right. All right, let us move on. All right. So, as I said earlier, I am just continually amazed at what you can do with LLMs, and they can do a lot. At your direction, you can ask an LLM to generate poems for you, literature, marketing materials, pretty much anything you can imagine. And I think what you can imagine is the true limit. And if I think about my own use of say ChatGPT over the last year, every aha I have is really about my own brain thinking of a different way to ask it to do things. Sometimes I think silly things like, oh, it couldn't possibly do that, I'm not going to type it in. Well, you know what? You can't wear an LLM out. So just ask it questions, ask it crazy stuff, ask it to do stuff you think it can't do, and you will be amazed at some of the stuff that it can do. You will also run into some of the limitations of it, as you'll see. Some other things you can do with it is you can get it to role play with you as an expert in some case, or a persona in certain situations. I was writing something, and I thought it looked good, but then I thought, I wonder what this would look like if Hunter S. Thompson wrote it. And so I said, hey, can you rewrite that in the words of Hunter S. Thompson? And sure enough, it had a very gonzo feel to it. I asked it to, you can have a lot of fun with these. I also asked it in a different occasion to say, reword stuff as Yoda might say it. And that was somewhat humorous. So there's a lot of things you can do in this role play as experts, personalities type of realm. Another big area where LLMs work well is in analyzing information or summarizing it or reinterpreting. This can include translating from like English into any other language. Finally, the last thing that we see on here is generate code. As software engineers, this is really where it is most important for us professionally, although all these other aspects I'd say have been very interesting, fun, and really productive to use in a lot of different ways. So with this in mind, let's go to the next slide, which you all might be able to guess has to do with what LLMs can't do. So LLMs are not able to provide 100% correct answers. They have no way to know what is really correct or not. They've just been fed a lot of data, a massive amount of data, and do their best to draw patterns from that and then answer based on those patterns. But because they are based on the data that they are trained on, you can imagine, I guess we've all seen that there is information on the internet that's not correct, believe it or not. So some of that information is slipped into the training, and there's no way for the trainers of these systems to really filter out information that is not factually correct. So that's one of the most important things to keep in mind as you work with LLMs, is that there's no way for them to be 100% correct. Or even to that fact, to even understand what you're asking. LLMs don't understand anything. They're not aware of anything. It's very tempting as you chat with these to feel like there is a human on the other end of the line that you're chatting with. But it's really important that you keep in mind that they don't understand anything and they are not aware of anything. It's purely a giant set of patterns that it puts together in the way that makes the most sense. And really, it's a probabilistic thing. So if you put in a prompt of whatever kind, it gives you the response based on all of the patterns it knows that has the highest probability of being correct and matching what your question was. Another limitation of LLMs is that they're trained on data up to some point in time. And so there will always be a gap between right now and then the data that they were trained on. So you can't assume that an LLM always has information as of yesterday, last week, or even last month. That's one thing that you have to keep in mind. The last thing, and this kind of comes back to these are trained on information from the internet. There's a saying in software engineering that for any given system, the saying is garbage in, get garbage out. If you put garbage data into a software system, there's no reason to think you're going to get valid answers out of it. And AI is just another system that stands up to that saying. And we know that there's garbage data out on the internet. So we know that LLMs can have biases or be partial in different ways. It's important for you as a user of the LLM to be the human in the room who analyzes the data and makes sure that you have to be the ultimate judge and arbiter of what comes out of this. So you can't trust these to be correct all the time. Let's move on to the next slide. Make sure I got all the important points here. I believe so. Okay. Now, because of the kind of some of the risks of using AI, as part of a Hack Reactor bootcamp, you will learn how to use AI the right way, and in two different ways is the right way, as a learner and then as a software engineer. Now, as a learner, there's some really important things here. These LLMs can be very useful in your learning journey. You can configure an LLM to act as your own personal tutor that you can ask questions to until a human might be blue in the face. The LLM will keep going. So they can be really useful. So if you've gone to class and you've gotten some information from the instructor or read some of the materials and you kind of get it, you can go over to the AI and say, hey, you know what? I kind of get this concept of if statements, but it's a little fuzzy. Can you help me understand it better? And it'll jump right in and start giving you, trying to give you descriptions and help you understand it better. Usually the way these are wired, it'll give you a description, then say something like, does that help? Or can I go deeper for you? And so you should feel free to just follow along the conversation as if you were talking to a real human and use it as a tutor. They can be very useful that way. They can be very useful for researching stuff. If you're not really sure what the right way to approach a problem is, ask ChatGPT, or I'll say ChatGPT probably for the rest of this talk, but also keep in mind Claude and Gemini are other similar tools to use. I'm not specifically biased towards ChatGPT. It's just what I've been using at the moment, but these are all quality tools, and I don't mean to imply that any one of them is better than the other ones. The other way that they can be useful is for kickstarting your projects. When you're starting a project, it's kind of like when you're writing a paper or something like that. That blank page can be really hard to stare at, and it can be hard to know where to get started. So that's one way. Another way that LLMs can help you is to get you some basic framework of your project up front. Now, the LLM is never going to know about the product you are building, right? But if you say, I want to build a to-do list, for instance, it can't know every little detail about the to-do list you want to build, but it can get you a pretty decent start on it. Now, again, you got to know how to program for this to be useful. If you don't know how to program and you say, hey, I want to build a to-do list, the AI can generate a whole bunch of code that may or may not really be accurate and correct. The only way to know that is to know how to program so that you can preview the code. It's almost like if you picture yourself as like a master tradesman and an apprentice. A master tradesman a lot of time will say, hey, apprentice, go do this work. And a lot of time the apprentices get the mundane and kind of boring work. Think about if y'all have seen Karate Kid, wax on, wax off, sand the fence, wax the car, all that kind of stuff. The apprentice gets these kind of mundane jobs. It's the job of the master craftsman to look at the work of the apprentice and make sure it's correct. So you can think of a GPT or an LLM as being similar. You can have them do a lot of work for you, but you are the, say, adult in the room, the master craftsman, and it's your job to verify that it's correct. And if it's not correct, then ultimately you have to own it. And anything that's any problems that come out of it, you have to own those as a professional. It would be very unprofessional, say, if I write some code and I submit it into our repository and someone says, oh, dude, this code broke the build or it broke these features. And I can't just say, oh, man, well, ChatGPT did that. It's ChatGPT's fault. This is my fault. I am the professional software engineer here, so I have to own that. And again, if I don't know how to program and I don't know how to write software, there's no way that I can serve that purpose. So I've gone quite a ways on the learner aspect. In your software engineering career, you can use these in ways, as I suggested here, by researching, kickstarting projects. The other way is with code assistants like GitHub Copilot, which I referred to earlier. We're not really going to talk about those much in this talk. In all the Hack Reactor boot camps, we do get into using Copilot, specifically learning how to use it and using it on projects. But I can tell you, for some of the projects I've worked on recently, again, I am amazed time and time again at how Copilot, for instance, it almost seems like it's reading my brain and is writing some of the code for me. It's massively useful, but again, I got to be able to check it myself and know that it's correct. Okay, let's jump into our next slide. So let's just go. This is kind of a reiteration of some of the things I've said here, but I think it's important enough to say them a couple times. Some do's and don'ts of using large language models. So on the do side, we're going to say use the LLM to help you learn new concepts and ideas. If you're in class and you don't have a solid understanding of something, ask the GPT to help you out. If you're in doubt, because these things can be wrong, I don't know if I mentioned the term earlier, but the term hallucination is used to refer to when AI systems put out information that is just factually incorrect. If you are not sure about what you're getting from the AI system, ask your instructor. They are the expert human in the room whose job it is to help you get through the course. The AI can never ever be a substitute for that very experienced and educated instructor in the room. Let's see. One way that you can use it in education is we provide a lot of different example code for you to work through so that you can exercise the skills as you get them. If you run through all those examples, but you're hungry for more, all you have to do is ask ChatGPT to create it for you. You can take a couple of the examples you have, paste them in there, and say, hey, ChatGPT, please make 10 or 100 more examples like this for me. And it will make them so you have all the exercises you could possibly want. Okay, let's look at the don't side of this. Don't, first and foremost, and most importantly, skip critical thinking. The whole system does not work if you aren't the critical thinking driver of the system. So think critically about this. Don't take the answers, accept them as they are. One thing that I found is pretty interesting, a use that has been growing more and more. My use of it is using ChatGPT instead of Google or DuckDuckGo or other search engines for searching. Now, a huge difference is when you get results from ChatGPT, it comes as though an expert is telling you what the answers are. In Google or DuckDuckGo results, you can see the actual links. You can see where it comes from. The bibliography is baked into it, so you know where this data is coming from. With ChatGPT, you don't. But a thing you can do is ask it for references. Like last night, as I was putting this presentation together, I asked it, what is the mass of Neptune? And it said, I don't know, however many millions of kilograms or whatever. And I said, where did you get that information from? And it immediately spin out a reference to a NASA website. And personally, I trust NASA to know what the mass of Neptune is. So anytime you get these types of things, you can always ask the GPT to give you a reference, and it will give you references back out to where you can validate and verify the data. Don't use LLMs exclusively as your primary source of learning. If you're in one of the Hack Reactor programs, you've paid good money and good time to be here. Take advantage of your instructors and the teaching assistants and the materials that are there. There's, as the director of curriculum here, I can say a lot of thought and effort and love and sweat and tears has been put in to make a very, very high quality course for you. So please use those materials as your primary source. The LLM is something that can help you along, but please don't underestimate the importance of the knowledge coming from the instructors and the materials. I guess this kind of goes along with it, but don't ignore your instructor. If you're wondering like, oh, ChatGPT said this, the instructor said this, I'll give you a hint. Your instructor's right. So with that, let's move on. Okay, now we're going to talk about how we interact with LLMs. We're doing good on time. So what I'm going to do is walk through some different patterns, and then we will actually go to ChatGPT and do some live prompts and see what kind of responses we get out of it. So first, we're going to look at three main patterns here: generating content, analyzing and transforming information, and engaging in dialogues. Let's jump into those individually. First off, for reference, when we get there, if you want to follow along, you can use chatgpt.com. This is available for free. And the free model is, well, I haven't paid for it at this point. I've been meaning to, but they keep improving it. And what's out there is pretty awesome as it is. I would also highly encourage you to check out the other tools out there like Anthropic's Claude and Google's Gemini models and other ones as they come up. ChatGPT is by no means the only kid on the block here. Okay, generating content. So when you're interacting with a tool like ChatGPT, what you type in is commonly called a prompt. And so that is just the way that you are prompting or asking the system to answer your question, create whatever you want. Whatever you type in there is called a prompt. Pardon me one second. I have children here, and they seem to have escaped out of their cages. Hold on just a second. All right, sorry about that. I don't think I need to say it, but I don't keep my children in cages. I just like to be funny sometimes. But there's a reason I'm a software engineer and not a comedian, because I'm a much better software engineer and not that funny, my wife tells me. Okay, I see a question here. I will get back to this question. Well, actually, Allison says, Gemini usually lists the reference at the bottom of the answer. Cool, thank you for adding that in there, Allison. I just started working with Gemini recently, and I didn't notice that. But that's a good thing to note. But also note, if it doesn't give you those references, you can ask it, and it will give you references back to where the data came from. Okay, so back to generating content. So the type of prompt, and you can really, when you interact with these, you can do it in a very human way. You don't have to write things exactly some way, this way or that way. It will, it will work over spelling errors. It will work over grammatical mistakes, all kinds of things. I would say the more accurate you are, the better of a response you will be, but you shouldn't get hung up on it. Like, don't spend 5 minutes trying to think of what the best way to prompt it is. Just type it in there and see what you get, and you can refine it if you want. But I encourage you to just experiment and play with the things. So an example of a generating prompt might be, write a short story about, and then whatever topic you're interested in, and see what it generates for you. When you're working with this, you really end up with kind of like a conversation. So if it generates something for you, you could say, hey, that's really nice, but could you make it longer or be really specific? I'd like that to be 10,000 words. And it will, it will do what you ask it to do. I'll say sometimes I don't know where I get this in my head, but I feel maybe slightly guilty about overworking it. And I like have it do a bunch of math calculations, and I think of something else. And I'm like, oh man, I don't want to burden it with it. Wait, what am I burdening here? This is a computer. I can burden it all I want. That's why we have computers. So make it work. Ask it to do stuff over and over and over. Refine these prompts until you really get what you want. Just try these out. One thing I would say is play around with modifiers. Like I said earlier, like I kind of have fun asking it to write stuff in different voices. So you can suggest different styles or genres or perspectives for it to assume, and it is surprising how well it can do this. One thing you could do, I mean, there's so many ways you can play here. You can ask it to start, you can write your own beginning of a story. I don't know if any of y'all have seen the game where somebody starts to write a story and they pass it to the next person and they write part of the story and they pass it on. Start writing a story and then pass it off to the GPT and say, hey, take this to whatever conclusion you want. Those can be very interesting. Along the same sides, because this is about coding, the prompts we have here aren't about coding because we want it to be fun, but all these things apply for coding. So, hey, could you please write a program that plays tic-tac-toe, for instance? Boom, it'll spit out all the code for you to have a tic-tac-toe game. Let's go to the next step or next kind of way of working with LLMs is what I might call analyzing and transforming information. So summarizing a piece of text is a common task. So if you have a giant article of some kind, you could say, hey, summarize this for me. Please summarize this in 100 words or 500 words or one paragraph, whatever type of summary you need. This can make going through if you're doing research tasks, this can make it a lot easier and faster for you to do research such that you can get through large bodies of text very quickly, possibly now I don't want to paint the picture here that you can just do cliff notes on everything, right? Sometimes you really got to read the whole book. And so I would say, like in this case, summarizing things might be useful for you to find out a given source that, hey, this is where I want to spend my time and really read the whole thing, right? So you summarize 10 different articles and you're like, oh, this article, I'm going to go read the whole thing. There are details in the original human written things that are invaluable. And when you process that stuff through the GPT, you're losing information, right? Summaries are nice, but you're losing information. So don't forget about the value of that original content. I liked at the bottom here, invent your own language like Pig Latin. So translating is another thing you can do here. You can translate to real languages or Pig Latin or whatever, but that is just one aspect of analyzing and transforming. Engaging in dialogue. So this is the third and final kind of pattern that we'll follow here. And like I said, a lot of these things, if you come at this from kind of the perspective of how you use a search engine, you will start off with kind of single pointed things. Do this for me. Get me this information. What is this answer? But as you work with it more, you'll find that a dialogue type pattern works really well because you can dig in, you can refine, and if you think about maybe when one of the first times you used the internet and you were just like amazed at how deep the rabbit hole goes and you can just keep digging deeper and deeper and deeper on a topic, this is like that all over again. So thinking about this as a dialogue that you can refine and shape as you go is a key part to utilizing these and having fun with them. Okay, so this is a specific kind of dialogue starter. And so I'm going to put this in the chat here so that y'all can, take it and use it. Is this going to let me actually? No, because it wants to. Okay, I can go over here. Copy this and then put it into chat. And this is your tutor starter prompt. So if you type this, so we were just talking about dialogues. If you start a dialogue with ChatGPT or one of these other tools and you paste this into the tool at first, you're essentially putting the GPT into tutor mode. You're saying it, hey, I want to learn stuff. I don't want you to just give me the answer. I want you to help me figure out the answer on my own. So if you put that in there and then start asking your programming questions, you will get an experience that is a lot more like having a personal tutor that is helping you learn rather than somebody who's like doing your homework for you and just getting you to pass the class. On that point, I want to say this one more time. If you're spending the money and taking the time to sign up for one of our classes, it is vital that you learn this stuff on your own. There's no amount of AI today or in I don't see it changing in the next 5 to 10 years, honestly, where you don't have to learn how to program to do this kind of stuff. And if you think about it, like your brain, it needs exercise to learn new things. You have to try hard things and be challenged by them and work through them. That's how you learn, engage knowledge. And it's a lot like going to the gym. You wouldn't pay somebody to go to the gym for you, right? Like the workout would get done, but you're not getting any stronger or healthier out of it. And your brain works the same way. I don't know, I don't want to just beat this like a dead horse, but it's vital that you learn how to do this and challenge yourself. Use ChatGPT to enrich your learning experience, to get more challenges for yourself, but please don't use it to eliminate the challenges, because if you eliminate the challenges, you are eliminating learning. And that's just the fact of how the brain works. This is, I think, our last slide here. And these are some examples of, if we bring all these different things together, you can take this idea of generating content, analyzing and dialoguing to generate really rich prompts that can give you really rich experiences and get very interesting results from. So here's a couple examples of prompts that you might try out. So first one is write a short story about a robot discovering its first emotion in the style of a noir detective novel and the perspective of a robot. Interesting. Summarize this research paper on renewable energy into bullet points and focused on the potential economic benefits. Interesting. Ask me a question about machine learning as if you were a journalist preparing for an interview. So that right there is another way you can use this. After you've finished your boot camp, the next step after a boot camp is getting a job. You can use your GPT to help you practice for the technical interviews that you're going to be doing to get those jobs. The number of ways you can use this, just it's amazing. They're growing all the time, and the more you play with it, and the more I would say you're daring to just ask it crazy questions, the more you will learn with it. With that, we are at question and answer time. So I'd love to take any questions. All right. I see a question here. This question is, what level experience does a dedicated Hack Reactor grad have upon completion of the boot camp? How does this translate to junior level, mid, or senior level job openings? The level of experience. With all of the Hack Reactor bootcamp programs, when you graduate, you will have built a full stack application. So this includes all of the HTML and CSS on the front end to make it look like what it looks like. This includes the back end programming, which is where the business logic of stuff happens. So let's say I mentioned a to-do app earlier. What are the functions of a to-do app? We want to create a new to-do item, right? We want to check a to-do item off. The HTML and CSS, that kind of is the interface you see. The back end is where the things actually happen, where a new to-do item gets created or where it gets checked off. Another part of that, I'd say the back end of the back end is what are usually called databases. You will learn how to create databases, the structure of databases, and then how to query databases to get data out of it. So that's generally what we consider the main pieces of full stack. So that's the front end, the back end, where the business logic happens, in the database. So you will have built several applications like that. As far as the junior, mid, senior level, graduates are at a what I would call a junior level. I would say there's still a lot that you can learn about computer science. The point of these boot camps is really to get you employable in the shortest amount of time possible. I think I mentioned it earlier, but I've been working in this space for a little bit over 10 years, and that's been the goal in all the places that we do. Computer science is a type of profession where the learning never ends. Like, I don't care if you start with a boot camp or you start with a 4-year degree, you still have a life of learning in front of you. And we've really taken a lot of time in consideration to tailor boot camps into getting you the minimal necessary information you need to get that first job. But when you get that first job, I would say is when the real learning begins. All graduates should be very, very capable of getting a junior level web developer job. But like I said, that's where the learning really begins, and that's where you can take it in whatever directions you want. Somebody at the very beginning asked, how do I get into doing AI work? Well, learning how to program is step one. And if you get yourself a job as a junior web developer, you've opened the door for you to continue learning in whatever direction you want. And if it's in the direction of, writing AI systems, then that's the direction you can choose. Next question from Megan S. Can you please touch a bit on copyright related to AI tools that create images? Not really. That's a very, very interesting place. I think IP attorneys and lawyers are having a lot of fun with that right now. But I am not an IP attorney. IP means intellectual property, for those of you that aren't familiar. And so it's not something that I can really speak about. If you had a more nuanced aspect that I might be able to, but again, that's not really my area of expertise. And okay, Isaac here asks, does Hack Reactor provide an on-site boot camp? At this point, no, we do not. All the boot camps we offer are remote. I would say that while there's a part of me that misses the in-class experience, we've done a lot of work, especially in our newer boot camps, to make them say they're remote first. They are meant to be remote. So it's not an in-person class that has just been COVIDified, if you will, and made to work remotely. But we put a lot of energy into really making your experience in the classroom as educational and enriching as possible, but while also opening it up to a lot more people. It's a lot harder to, honestly, financially justify having campuses, and by doing so, those only work for those small, metropolitan areas where they're at. By offering remote classes, this really opens it up to all people. And that is really the idea. One of the core ideas of boot camps is kind of the democratization of this type of education so that all people can become software engineers if they want to. Another question from Allison. The remoteness isn't something that is negative or something that takes away from the information gained. Hey, thank you for saying that, Allison. That's what I truly believe, and that's what my day-to-day job is to continue to refine and improve the process to make it better and better. And I'd say there's some tools that the remote allows that just wouldn't even be possible with in-person. Any other questions? I'm going to stop the share here and we can... we got some more questions. Keep them coming. Here's a question from Anonymous. Is it an oversimplification to say ML learns from LMs and LLMs? Could AI use ML to make decisions? Okay, so so AI is the broadest category of all types of systems that attempt to do human-like tasks. Machine learning, or ML, is a subset of AI systems that specifically know how to learn. And basically what that means is you code it and then it continues to learn. Systems that aren't machine learning, you code it once, and if you ever want to change it or have it expand, you have to recode it or add to the coding of it. And so language models and large language models as well tend to be neural networks based on neural network technologies, and neural networks are a type of machine learning. Any type of neural networks in general, one of the things they can do is help make decisions. And so that could be categorizing, again, is this a picture of a frog or the moon or whatever? So that's a type of decision. Based on the data that you feed it, yes, neural networks can work very, very effectively at making decisions. And again, language models are a type of neural network generally. Next question from an anonymous. Is full stack still a job for humans, or has AI taken over full stack positions, so it's better to learn back-end languages? That's a good question. AI has not taken over any of these positions. Like I said, there's a benchmark that is used to, there's all kinds of benchmarks that are used to rate AI's capability to do different tasks. There's a specific set of benchmarks that are based around software engineering tasks. And currently, AI is able to do about 5% of those tasks. And so these are the most mundane aspects of programming. And they're the types of things that after I've done it 100 times before AI was here, I thought, oh my gosh, how many times do I have to do this mundane thing that really takes no thinking at all? And it's just rote doing the same things. That's where AI really shines for software engineering, is taking over those mundane tasks that I really don't like to do. I like software engineering because it presents a constant stream of challenges. It's like if you like playing games, being a software engineer is like getting to play games all day long. And so I like the challenges. I want problems that make me think about stuff. The parts of my job that are mundane, that's not why I'm a software engineer, and that's where AI shines, and that's where I love using it to come in and take over those parts so I can get to doing the fun stuff. Another question from Allison. Keep them coming, Allison. As a Hack Reactor grad, is there a place we can go to gain more knowledge on machine learning? I have noticed quite a few jobs in the area as well as in the software engineering field. Well, there's well, I would say start with your search engines. Start with ChatGPT and ask it. Really, go to your ChatGPT and say, hey, what do I need to do to learn to be an AI engineer? I can give you some hints. Learning about neural networks would really be a good starting point because, like I said earlier, most of the main advances in the artificial intelligence have been in the realm of neural networks. I could say for myself, I took a course on Coursera, it was about 6-7 years ago. It was how to write neural networks from scratch. That was very educational, although I don't think it's really necessary to go down to that level at this point. There's a lot of tools. In one of our boot camps, we teach Python, and Python is one of the primary languages used in data science. There's a lot of toolkits in Python that allow you to write neural networks without having to get into the calculus, if you will. The class I took gets into the calculus, and call me a nerd, but I love math and I loved the calculus part, but not everybody does, and you don't have to. So there are libraries you can use in Python, but I would go into your LLM of choice and ask it for references, and it can point you at courses, it can point you at books, it can point you at articles. Good old search engines work as well. Yeah, I hope that's useful.
Okay, great. Now that we're almost at time and we worked through all the questions, I just want to say a huge thank you to Daniel for all of your insights and answering all these questions. I think it was a great entry. Maybe this is the first time, some of the audience members have heard about some of these terms, or if you're already coding and exploring future job opportunities with AI, I think it's a great starting point to learn about some of this stuff. So thank you again, Daniel. Thank you everyone so much for joining us. This event has been recorded, and in the next 2 business days, I'll be sure to get this recording and any resources that we shared out to all of you. So again, just want to say a huge thank you all for spending the past hour with us, and hope that y'all have a great rest of your day.
Thank you, Jenna. Thank you, Jeff. And thank you all for joining us.
Bye. Thanks, everyone.